Hello everybody. Now we come to the video clip number 10 of this chapter 3. So this clip is all about the arc length and the curvature. And don't forget that right now we are talking about the vector function RT, which is consists of the first component FT, GT, and HT. Okay, and sometimes it may consist only two components, which is F and GT, depends on how many dimensions that you are talking about. Okay, so in this chapter we are going to talk about the length of the curve RT. Okay, depends on, like, for example, if your T is in the interval A to B, and then what is the length of this kind of curve. Okay, just like that. And another concept is curvature. Okay, and as we go to that concept, we'll talk about the curvature again. All right, so let's look at the first one, the arc length of a function. Okay, so the arc length of the function vector function RT is actually defined by the integration from A to B. Okay, so this one is the arc length of this curve within this interval, okay, from A to B. Then it is the integration from A to B of a square root of each component derivative. You see, each component derivative, and then take a square. Okay, and you find a integration with respect to t, or you can write down in a compact form as the integration of A to B of the length of r prime dt. Okay, that's very simple. But why is that we got this one? Because we just look like the curve like this. Okay, in actually you don't really need the axis. Okay, so this is the curve in three-dimensional space RT. And then for example, if you look at this one, you are going to try to subdivide, okay, this curve into several pieces. Okay, and then at each and every piece you are going to approximate it by the tangent line, okay, or the tangent vector. Okay, and what is the tangent vector of this one? It is simply r prime, okay, at that particular point. And then you are going to, because we finding the length, right, the length of the curve, so actually you finding the length of the tangent vector, okay, at each and every point over here. So it's look like a piece of straight line, right? So it's a piece of straight line, and you add them up together, okay, from the t equals to A to t equals to B. So as you add them up, it means that you are going to find the integration. Okay, so it is the integration of the length of a small tangent vector along this interval from A to B. Okay, so let's take a look. For example, the first one, you want to find the length of the circular helix, okay, that is starting from this point to that point. Okay, 0, -1, 0 to 0, -1, 2. Okay, so what you need to really know is that what's the t at the beginning and the t at the terminate point. Okay, and if you look at again your curve RT, you should be able to see that the last one determine the t immediately, right? Because the last one is just the t itself. So it means that this one should be t equals to 0. So you check it again. If your t is 0, then you got a -1, which is the second component, and you got your 0 as the first component. How about this one? This one actually we have a typo a little bit. Actually, this is let me change. This one should be 0, -1, and 2 pi. Okay, We forgot the pi. So here your t should be, because of the last one again, so your t should be 2 pi. So to check it, as you plug in 2 pi, the cosine of 2 pi is simply 1. So you got a negative 1 right here. And the side of 2 pi is simply 0. So this is the A and the B that you need to find the length from this 0 to 2 pi. Now what you are going to find is your length. Let's say L of AB, which is 0 to 2 pi. So it is the integration from 0 to 2 pi of the length of r prime t dt. So what is your r prime? The first component derivative, you got cosine, you got actually to find a derivative of cosine, you got negative sine, but you have this negative, so you got a sine and you got a 1. Okay, finding the length. So this one, the integration from 0 to 2 pi of a square root of cosine square t, sine square t, and 1 square, which is simply a 1. So this is a pretty simple trigonometric identity, right? This is 1. So actually you got the square root of 2, and then integration from 0 to 2 pi dt, and it just simply square root of 2 t, and you evaluate your t from 0 to 2 pi. So you got 2 pi square root of 2 as the length of this helix, okay, from t equals to 0 to t equals to 2 pi, or from this point, okay, the point 0, negative 1, 0 to 0, negative 1, 2 pi. All right. So as you can see that it may cause some difficulty, okay, on your integration if this square root contains something that is difficult for you to evaluate or to find the integration, okay, and that will be something in terms of calculus 1 that you have learned before. Okay. The next concept, after you have learned the arc length of the curve, it is the so-called a curvature. Okay, at the beginning the curvature in terms of math will be difficult to understand. However, as we continue and we go through one of the example, then you should be able to understand the curvature more. So in math, the curvature of a curve RT is the magnitude, okay, and we use a kappa to represent the curvature. It is the magnitude, okay, of the difference of the t divided by a difference of the s, or it is a derivative of a capital T with respect to an s, okay, where your capital T right here is a unit tangent vector. Okay, we hope that you still remember what we did before, that the tangent vector is actually your r prime t, but because you need this unit, then you are going to divide your r prime by their own length, which is the length of r prime, just like this. So this is your capital T. Of course, the capital T, it is a vector. Okay, so this was a unit tangent vector. What's the S? The S is something that you have before. However, what you have before is the integration from A to a fixed number B. So this one, it is the arc length function. So you start integration from the starting point A, but your end point is simply a variable t. Okay, depends on what the t that you are going to input here. So your S depends on t, and it is the arc length function. So the one that you integrate is the length of r prime t dt. Okay, so by using the chain rule, you can say that this was actually the t, because your capital T it is actually the function of a small t, and your s is also a function of a small t. Okay, so the one on the top is simply a derivative of a capital T, and how about the one on the bottom? You can just simply use the fundamental theorem of calculus, right? Because here is the integration, there is the derivative, so as they meet, then you got r prime t out of it. And don't forget that we still have the absolute value or the magnitude, so this one you should find the magnitude as well. So it means that your kappa, or the curvature, is the ratio between the magnitude of your derivative of a tangent vector, okay, over the length of your r prime, okay, the length of your r prime. Okay, as you look at this one, is still not that understandable. Okay, let us go to another theorem first, okay, because usually, I mean, if we are not forced to do, okay, we are not going to find the capital T prime. That will be pretty difficult, because as you can see, your capital T, it is a fractions, right? It is really not a fraction, it is a multiple of 1 over the length of r prime multiplied by the vector r prime. So if you want to find your capital T prime, you're going to use a product rule, which is not that fun to do. Okay, so let us introduce another formula to find a curvature first that we usually use. Okay, so here the theorem, the curvature of the curve is actually given by the r prime cross r double prime, and find the magnitude over your r prime cube. Okay, so this is the curvature. So let's look at this one. If this one is your r, then what's your r prime? Okay, this is your rt. So your r prime, it is 1, 2t, 3t squared. What's your r double prime? It is 0 to 6t. Okay, but what you need to find is the is 2 kappa. One kappa, one curvature is a curvature at the general point t, and another thing is at the point 0, 0, 0. So this one is actually when your t is 0. So let's look at the kappa at the general point t. So what you need to find first is the length of your r prime cross your r double prime t. Okay, so before you are going to find the length, you just find this cross product first. So you got I take k, so your r prime is 1, 2t, 3t squared, 0 to 6t. So you are going to do the cross multiply, the diagonal multiply. So the first one, you got 12t squared, and the second one, you got 0 on the j. You see the 0 on the j, and the third one, you got a 2k. Okay, and then you do the upward diagonal. So the first one, you got a 0, and then this one, you got a 6t squared I, but it is upward, so it is, oh sorry, I forgot the I here. So it is the 6t squared I, okay, with the negative sign, right? And then the last one, it is 6t and j, so you got a negative 6tj. So you add them up, you got 6t squared, negative 6t, and 2, okay, for the k, right? So it means that the curvature at the general point t, it is your length of 6t squared negative 6t and 2 over the length of your r prime, which is 1, 2t, 3t squared raised to the power 3. So this is the common mistake that you forget that cube power. So here it is the square root of 36t fourth, 36t squared and 4, and then over the 1 plus 4t plus 9t fourth raised to the power 3 over 2, right? Because the length will be the power of 1/2, and then this cube you got a 3 over 2. So this is your kappa at a general point t. So if you need your point t to be 0 so that you evaluate the curvature at this particular point, you can simply replace your t here by 0. So you got a square root of 4 over a 1 raised to the power 3 over 2 or 2. Okay. However, in practice, usually you are going to find a curvature at a particular point. Okay, usually you do it like this. So what we really find, okay, is the r prime cross r double prime at this particular point 0. Okay, so you are going to find this cross product at the point under consideration, okay, which of course will be pretty easy, okay, comparing to the one that we just did, because lots of places will replace by 0, and then you are going to find the determinant very easy. Okay, so if you want to find the curvature at the particular point, you replace that particular point t first, then you find the cross product. That will be a lot better. Okay, now this is the example that I told you, like that you are going to understand what the curvature is. Okay, so the curvature, I mean, to me, is to measure how curved the curve is. Okay, so that's why it's saying that the curvature of a circle of radius a is 1 over a. So what does this mean? If the radius is big, okay, if the radius is big, then a curvature is small, right? Because it is a reciprocal of a big number. If a radius is small, then the curvature will be big. Okay, why is that? If the radius is big, your circle will be pretty big, right? Just look at the, let's say that you're talking about the earth. Let me use the blue one. Okay, comparing to the red one, which is a small circle like this. Okay, so if you look at the blue curve from very far, okay, from a very far apart, then instead of you see the curve, you see something like a straight line. Okay, right? It's look more as a straight line like this. However, as you look at the small one, even you look at from far away, you still see it as a curve, not a line. Okay, so that's why I told you that the curvature actually measure how curved the curve is. Okay, so let us try to find the curvature of this circle of radius a. So when you're talking about the circle of radius a, usually the vector function representing the circle will be a cosine t, a sine t, and 0, because it is no elevation on the z-axis, right? So you got a 0 over there. So your r prime t it is negative a sine t, a cosine t, and 0. And your r double prime t, it is negative a cosine t, and then negative a sine t, and the 0 at the last component. So to find the curvature, don't forget that you need to find r prime cross r double prime and find the length over your length of r prime cube. Okay, so you need to find the cross product between this r prime and r double prime first. So the cross product will be the I, the j, the k, and then negative a sine t. So let me expand it a little bit, and then j a cosine t, and the k 0, and negative a cosine t for r double prime, negative a sine t, and then your k is 0. So you do the diagonal multiply. So the first diagonal is 0, the second diagonal also 0, but the third diagonal survive. So you got a square sine square t k, and then you do the same thing with the upward diagonal multiply. So the k survive, so you have negative a square cosine square t k, but it is the upward multiply, so you have to have the plus. Okay, then it is 0 again, sorry, it is 0 here, and then it is 0 for the j as well. So only k that survive, and it is 0 0, and then sine square and cosine square becomes 1, so you have the a square left. Okay, so it means that this one, the length of the cross product becomes the length of 0 0 a square, and then the length of your r prime, it is a square root of a square sine square and a square cosine square t, and then 0, right? Rest of power cube. So here, the one on the top, you got a square as the length. The one at the bottom, because you have a sine and cosine, taking a square root, so you got a out. So this is a cube. So after you do a cancellation, you got 1 over a as your curvature. Okay, so as what you need, because the curvature of the circle, if it is a big circle, the curvature is small, so the curve look more like a line. But if your radius is small, the curvature will be pretty big, because the curve still look like a curve. Okay, so the curvature is actually measure how curved the curve is. Okay, so we are going to stop this video clip right here, and then the next one we are going to talk about some other so-called like tangent vector. Okay, usually it's look like a tangent vector, but then it will be some other vector that is related to the tangent vector, as we have the vector function given. Okay, so we'll see you then. Bye bye.